Okay, so number 37, we have a 25-gram object moving to the right at 20 centimeter per second, overtakes and collides elastically. Look, boom. This word right there is important. If a problem tells you that the collision is elastic, then what are they saying?
It's elastic.
They're saying it's elastic. They're saying what?
Momentum and kinetic energy are conserved.
They're saying not only is momentum conserved, because momentum's always conserved. Momentum will always be conserved. But if the problem specifies that it's elastic, then a second thing is conserved as well, and that second thing is kinetic energy. Okay? Now what if the problem doesn't say that it's elastic? Then you assume it's not elastic, and then therefore only momentum would be conserved. Does that make sense? If they don't say elastic, then the only thing conserved is momentum. But if they do say elastic, then momentum and kinetic energy are conserved. All right, so I wrote equations out here. Equation number one here, what's this equation? Conservation of momentum. Equation number 2 is conservation of kinetic energy. All it's saying is you take, your total initial kinetics, and that's going to equal your total final kinetics. So look, you could solve this problem, because this problem has two unknowns. They want us to find the velocity of each object. So how many unknowns is that? They say find the velocity of each object after the collision. So how many unknowns is that? 2. We're looking for V1 final. That's a question mark. And we're looking for V2 final. We have the 2 initial velocities, but we're looking for the 2 final velocities. If you have 2 unknowns, how many equations must you have? 2. Now, so what are the 2 equations that you have for an elastic problem? You have conservation of momentum, which is equation 1, and you have conservation of kinetic energy, which is equation 2. You do not want to try to substitute these 2 equations. If you try to substitute this equation and this equation together, is it possible to do it? It is possible, but it's going to be extremely hard. Why would that be extremely hard to substitute those together? Because in the kinetic energy equation, notice that velocities are what? Squared. If you don't know what I'm talking about, just try substituting those equations together. It's going to be miserable. Okay, so this third equation, now dudes, where does this third equation here come from? I mentioned this in our lecture. This third equation is a very handy-dandy equation, and where does it come from? From the first 2. If you substitute the first 2 equations together, you're going to get the third equation. So long story short, how are we going to solve this problem? We're going to use the first equation, and we're going to use the third equation. Much easier. And basically, this is 2 equations, 2 unknowns. Now, as if this problem's not difficult enough, they give it to us in grams and centimeters. Look, it really doesn't matter. For this problem, you could leave this in grams and centimeters. It's fine, because you're going to end up getting ratios anyway. It's not like you're solving for a Newton or a joule or anything like that. But look, I found over the years, kids can be very easily confused about well, dude, when does it have to be meters? When does it have to be centimeters? What, grams, kilograms? In general, you want to be in kilograms and in meters. So what I did, I solved this problem. I converted that into meters, and I put the masses into kilograms. Okay, so here's how I solved it. I took the third equation and I solved it for V1 final. So V1 final is going to equal V2 initial plus V2 final minus V1 initial. And then go ahead and put numbers in right now. That's what I would do. So let's see. So rearranging that one more time, that's going to be V2 initial minus V1 initial plus V2 final. Now, we have V2 initial and V1 initial. So V2 initial is 0.15. V1 initial is 0.2. So what's V2 initial minus V1 initial? That comes out as negative 0.05. So this equation here is V2 final minus 0.05. And I'm going to leave units off, guys, because otherwise it gets really messy. I'm probably going to get fired. Spaldo, you left the units off. Okay, now what are we going to do with that equation? So we have V1 final in terms of V2 final. We're going to take this and do what? Plug it in up there. Okay, so I'm going to rewrite this equation. So now we have M1. I'm plugging into this first equation right here, this first equation. M1 V1 initial plus M2 V2 initial equals M1, okay, V1 final is V2 final minus 0.05 plus M2 V2 final. What is the only thing missing in that equation? V2 final. So all this is substitution. Okay, so we got to distribute the M1, right? And you know what? Let's go ahead and plug numbers in. It's going to shorten this up. So M1 V1 initial, when you multiply that out, M1 V1 initial comes out to be 0.005. I'm leaving units off. Plus 0.0015. That's M2 V2 initial. You can check that. And then this is going to be M1 V2 final minus 0.05 M1 plus M2 V2 final. Okay, so this is going to be, so add those together. That's going to shorten this up. 0.0065 equals now M1. So this is going to be 0.025 V2 final minus this guy right here is 0.0013, and then plus, so M2, that's 0.01 V2 final. Okay, so this ends up, when you simplify that down, you get 0.035 V2 final equals 0.0078. So V2 final comes out as 0.223 meter per second. Put it back to centimeters and you get 22.3 centimeter per second. Positive. So the answer came out positive. So what does that tell me? To the right. So look, if I haven't said this, elastic is a pain in the booty, dude. You guys get that? You feel that? You feel me? If you get a problem on a test where it says the collision is elastic, you're just going to say, oh, dang, dude. Dang, dude. Dang. Right? Why? Because it's going to be your two unknowns. You have to substitute together. It's just a lot of algebra. Okay, so V2 final comes out as 0.223 meter per second. And how do we get V1 final? Dudes, how do we get V1 final? Plug back into this thing right here. So V1 final is going to be V2 final, which is 0.223 meter per second minus 0.05, which gives V1 final as 0.173 meter per second, which is 17.3 centimeters per second. So this is 0.173 meter per second, positive, meaning to the right. Guys, you will have elastic problems where one of your velocities comes out negative, which means what happens to the what happens to the object that came into so you have like an object that slides in, it collides. What if your velocity is initially positive, but the final velocity is negative? What does that mean? That means it what? Bounced back.